Optical instruments, the microscope. That is simple microscope. Simple microscope એટલે તમે magnifying glass લઈ અને જે magnified image જુઓ, તો that is simple microscope. Microscope તમને magnified image આપે, right? હવે તમે જ્યારે image formation થાય, આપણે magnifying glass થી જ્યારે magnified image જોતા હોઈએ, ત્યારે આપણે object અને lens વચ્ચેનું distance એવી રીતે maintain કરીએ કે image formation takes place on the side of the object. એટલે જે સાઈડ આપણો object છે એ જ સાઈડ image formation થાય. And that image formation should be at a distance which is known as the distance of closest approach. So image formation should take place at that distance or far than that. So distance of closest approach, એનો meaning એ થાય, so the distance of closest approach or closest comfortable distance of human being, that is 25 centimeter. તો closest comfortable or closest distance જે આપણે લઈએ ને એનો meaning એવો થાય કે minimum આટલા distance સુધી જે image formation થાય ને તો બરોબર છે, આપણને દેખાય. એનાથી દૂરનું દેખાશે, પણ એનાથી જો નજીક થઈ ગયું ને formation તો proper દેખાશે નહીં આપણને. So that is the distance of closest approach. Okay, તો એવું human being માટે 25 સેન્ટીમીટર છે. એટલે 25 સેન્ટીમીટર કે એના કરતા દૂર જો ઇમેજ ફોર્મેશન થતું હોય ને તો આપણે કમ્ફર્ટેબલી એને ઓબ્ઝર્વ કરી શકીએ, નહીતર આપણને પ્રોબ્લેમ થાય. ઓકે, નાઉ સી હિયર, સી ધ ફિગર, schematic diagram. The magnified image of the object is formed here. So the image formation takes place at closest comfortable distance D. Object distance is U. This is the observer observing the magnified image, and the image formation takes place on the side of the object. So magnification that is given by M equal to V by U. But we have the equation 1 upon F that is equal to 1 upon V minus 1 upon U. So from that we can write 1 upon U, that is 1 upon V minus 1 upon F. Okay, so we can write V into 1 upon V minus 1 upon F. Now take this V inside the bracket, so we can write magnification M that is equal to 1 minus V by F. Now here V that will be negative because the image formation takes place on the side of the object. Okay, and the image formation takes place at the closest comfortable distance D. So we can write V that is equal to minus D. So magnification M that is equal to 1 plus D by F. Okay, so this one is the concept of a simple microscope, and in it the magnification will be obtained as per this equation M equal to 1 plus D by F. Clear to all of you? Now in this simple microscope, suppose the image formation takes place at very large distance. Means the image distance that is too much large compared to the closest comfortable distance. Okay, so definitely આપણને ફાઇન દેખાવાનું છે. તો એ કેસની અંદર નોર્મલી આપણે કેવું હોય છે કે જો ઓબ્જેક્ટને ફોકલ પોઈન્ટની વેરી ક્લોઝ મૂકી દઈએ then image formation will take place at large distance. Okay, અને focal point થી થોડુંક અંદરની બાજુએ લેન્સ તરફ મૂકો તમે એટલે image formation will take place towards the object side. તો એ કેસની અંદર જો D આપણે લાર્જ લઈ લઈએ રાઈટ, એટલે કે ઘણા મોટા ડિસ્ટન્સ ઉપર ઇમેજ ફોર્મેશન થતું હોય તો D by F that will be large compared to 1. So we can neglect 1 and in that particular case simply we can write the magnification that is D by F. હવે એને આપણે અહીંયા આગળ ડિરાઈવ બી કરી શકીએ આ રીતે. જો એક સ્કીમેટિક ડાયાગ્રામ બતાવ્યો છે સેફ કે ભાઈ તમે object any height h, okay, suppose it is subtending angle theta 0 at I, okay, so angle subtended by object at I that is theta 0 and suppose angle subtended by its image at I that is theta I. So in that particular case we can write tan theta I that is equal to opposite upon adjacent. Opposite that is the height of image h dash, adjacent that is the image distance. Image is formed towards the object side, so we take it negative, so minus v. Similarly tan theta 0 that is equal to opposite upon adjacent. Opposite that is the height of object, adjacent that is the distance of object, so minus u. Now here if we take theta I and theta 0 very small, then in that particular case we can write tan theta I that is nearly equal to theta I and tan theta 0 that is nearly equal to theta 0. So theta I that is minus h dash by v and theta 0 that is minus h dash by u. But here u that is taken as d. Okay, now as per definition magnification that is h dash by h and that is equal to v by u આપણે થિયરી ની અંદર ડિરાઈવ કરી ગયા છીએ. So h dash equal to h into v by u. હવે જો theta I that is h dash upon minus v, so h dash that can be replaced by h into v by u. So h into v by u upon minus v as it is. V cancel, so simply we can write theta I that is equal to minus h by u. હવે આપણે આગળ ડિસ્કસ કર્યું if we take u that is equal to f, એટલે કે ઓબ્જેક્ટની પોઝિશન ફોકલ પોઈન્ટ ઉપર આપણે લઈએ તો ઇન્ફાઇનિટી ઉપર આપણું ઇમેજ ફોર્મેશન થાય. તો very close to focal point towards lens લઈ લો તમે, it implies that it will not be at infinity but it will be formed at very large distance. Okay, so u equal to minus f આપણે લઈ લઈએ, then we can write theta I that is equal to h by f. Now magnification, so that is given by the ratio of angle subtended by image at I to angle subtended by object at I. So we can write magnification that is h by f upon h by d. So that is equal to d by f also. It implies that simply we can say if d by f that is large one, then we can neglect this one and we can give the equation of magnification that is d by f. Clear to all of you? Now compound microscope, actually that is the system of two lenses in which one lens that is the smaller one, another one that is larger one, object is placed against the smaller lens, which one is known as objective, and the final image formed by this lens system is observed through this larger lens by the observer as shown in the figure. So this larger lens, that is known as eyepiece. Okay. Now here the first lens, which one is known as objective, will form the image of the object, and that image formed by objective lens, that will behave as an object for eyepiece, and then finally eyepiece will form the image. હવે જો ઇમેજ ફોર્મેશન કેવી રીતે થાય છે આખું રે ડાયાગ્રામ થી અહીંયા મેં સમજાવ્યું છે તમને. ઓકે, say here AB, that is the object, height is h, object distance, that is u. Now here take one ray parallel to the principal axis, so after refraction it will pass through the focal point. So it will pass through the second focal point of the objective lens. Another ray that will through the center of the lens. It will propagate without deviation. And now the image formation by objective lens will take place at A dash B dash, this one. Height of the image, that is H dash. Now this image formed A dash B dash will behave as an object for eyepiece. Now here eyepiece is adjusted in such a way that this image formed, that should be very close to the first focal point of eyepiece. આ eyepiece નું આ focal length અહીંયા આટલી બતાવી, મતલબ કે આ એનું focal point છે. Exact focal point ઉપર નહીં, પણ એનાથી close, right, towards the eyepiece. તો eyepiece નું એડજસ્ટમેન્ટ આપણે એવું કરવાનું કે આ જે ઇમેજ ફોર્મેશન થયું છે એ આ ફર્સ્ટ ફોકલ પોઈન્ટની વેરી ક્લોઝ હોય. Then the final image will be formed by this eyepiece towards the object. એટલે A dash B dash એ આના માટે object છે, તો એની જ સાઈડ ઉપર A double dash B double dash magnified image will be formed. અને એ magnified image માની લો કે capital D distance ઉપર form થયું છે, right? Now see here, this particular distance from objective to its second focal point, that is its focal length FO, then the first focal point to eyepiece FE, and the distance between second focal point of objective and first focal point of eyepiece, that is known as tube length, capital L. Okay, now suppose here this angle subtended at the second focal point of objective by the object height, that is theta, then we can write tan theta, that is h upon FO, opposite upon adjacent. Similarly, if this angle is theta, this will be also theta. So we can write again tan theta, that is this opposite adjacent h dash upon this adjacent L. Compare these two. So h dash by L, that is equal to h by FO. So h dash by h, that is L by FO, but as per definition h dash by h, that is magnification. So we can write the magnification by the objective lens, that is L upon FO. Now this A dash B dash is the object for eyepiece. Now this eyepiece that we can consider as a simple microscope discussed as in previous theory. So we can write the magnification by eyepiece, directly we can write that is 1 plus D upon FE, but D, that is large one. It implies that D upon FE, this ratio, that will be large compared to 1. So we can neglect one and we can write the magnification by eyepiece, that is D upon Fe. So magnification by eyepiece, that is D upon Fe. Now we already discussed in the theory, for a lens system, the resultant magnification of the lens system, that is given by M1 into M2 into M3 up to MN, that we discussed. So here the magnification of this compound microscope that we can give by M equal to MO, that is the magnification by objective, into ME, the magnification by eyepiece. So resultant magnification, that is ME into MO. So resultant magnification, that is equal to D upon Fe into L upon Fo. So this one is the compound microscope. Clear to all of you? Now see, in compound microscope, we observe very small object, magnified one. An object is very close to objective lens. But a telescope, that is also a lens system. It is also a system of two lenses, but in that the objective lens, that is large one, and eyepiece, that is smaller one. And in telescope, we observe distant objects, magnified one and clear one. Okay. So say here how the image formation takes place in telescope, that is represented here by the ray diagram. The concept is the same one. First, the objective lens will form the image of the object. That image formed by objective lens will behave as an object for eyepiece, and finally eyepiece will form the resultant image. So here the object is at very large distance. Okay, suppose the parallel rays from the distant object are incidenting on the objective lens. આ પહેલા lens ઉપર આવે અને large distance ઉપર છે આપણો object, એટલે જે rays આપણે લીધા એ અહીંયા જો આ parallel લીધા, right? So we can say here the angle subtended by the object at objective, that is this alpha. હવે ऑब्जेक्ट जो लार्ज डिस्टन्स ऊपर होय, राइट, तो एनु इमेज फॉर्मेशन ऑब्वियस छे, एना फोकल पॉइंट ऊपर थवानुं छे. तो ऑब्जेक्टिव लेंस नु सेकंड फोकल पॉइंट ત્યાં આગળ ઇમેજ ફોર્મેશન આપણે બતાવ્યું. This distance is FO and image formed, that is A dash B dash. Again here the eyepiece is adjusted in such a way that this image formed by objective, that is very close to the first focal point of eyepiece. Now eyepiece will form the final image of this one. Okay, now suppose the angle subtended by that final image, तो आ A dash B dash એ ઓબ્જેક્ટ ની જેમ બિહેવ કરશે આઈપીસ માટે, અને જો આ ઓબ્ઝર્વર પછી અહીંયા જે બેક સાઈડ ઉપર, એટલે કે ઓબ્જેક્ટ ની સાઈડે જે ઇમેજ ફોર્મેશન થશે અહીંયા આગળ એ ઓબ્ઝર્વ કરશે. સપોઝ ફાઇનલ ઇમેજ subtend an angle beta at the eyepiece. So as per definition, we can write the magnifying power, that is the ratio of the angle subtended at eyepiece by the final image to the angle subtended by object at objective. એટલે આપણા કેસની અંદર magnifying power or magnification, that is beta upon alpha. So magnification M, that is beta upon alpha. Now from figure we can write, see, tan beta, that is opposite. Opposite, that is A dash B dash, that is H. So opposite upon adjacent, adjacent, that is Fe. So tan beta, that is H upon Fe. Beta is very small. So we can write tan beta, that is nearly equal to beta, that is H upon Fe. Similarly, here in figure we can see tan alpha, that is again opposite, that is A dash B dash, that is H upon adjacent Fo. Alpha is again very small. So tan alpha, that is nearly equal to alpha, that is equal to H upon Fo. Substitute these values of beta and alpha here. So beta, that is H upon Fe. Alpha, that is H upon Fo. Resultantly, we will get the magnification in the telescope, that is Fo upon Fe. Clear to all of you? Now this particular telescope, that is refracting type telescope. આમાં લેન્સમાંથી રેઝ પાસ થાય, એનું રિફ્રેક્શન થાય, ઇમેજ ફોર્મેશન થાય, એટલે રિફ્રેક્ટિંગ ટાઈપ ટેલિસ્કોપ થયા. આનો પ્રોબ્લેમ છે થોડો એવો કે લાઇટ રેઝ લેન્સની અંદરથી મીડિયમમાંથી પાસ થાય એટલે વ્હાઇટ લાઇટ લેન્સમાંથી પાસ થાય ને એટલે એનું ડિસ્પર્ઝન થશે, કન્સ્ટિટ્યુઅન્ટ કલર્સમાં ડિવાઈડ થશે. એટલે ઇમેજ જે મળે ને આપણને એ થોડીક કલર્ડ શેડેડ હોય ને એ ટાઈપની મળે. That is known as chromatic aberration. બીજું કે પોઈન્ટ લાઇક ઓબ્જેક્ટ હોય એનું જે ઇમેજ ફોર્મેશન થાય એ સ્પોટ ટાઈપ ઇમેજ આવે. પણ આપણે નેક્સ્ટ ચેપ્ટરની અંદર એક ફિનોમિના ડિસ્કસ કરીશું, ડિફ્રેક્શન. So due to that, the edge of the image, that is blurred. એટલે એને સ્ફેરિકલ એબ્રેશન કહેવાય. તો આ જે રિફ્રેક્ટિંગ ટાઈપ ટેલિસ્કોપ્સ હોય ને એની અંદર આ બે પ્રોબ્લેમ્સ આવતા હોય છે. એટલે ઇમેજની ક્લેરિટીનો ઇશ્યુ આવે આના લીધે કરીને. તો Cassegrain developed reflecting type telescope. And see, this is the reflecting type telescope, that is Cassegrain telescope. In that there are two mirrors. Objective mirror, that is concave mirror. Rays from the distant object incident on the objective mirror, that is the concave mirror. Then after reflection, it incident on the secondary mirror, which one is convex mirror. And there is a small hole at the center of the objective mirror. અહીંયા વચ્ચે એક હોલ કરેલું હોય. So the rays which are reflected from the secondary convex mirror passes through that hole and you can observe it from the eyepiece. તો હવે અહીંયા શું છે કે રિફ્લેક્શન થાય છે. લાઇટ રેઝ કોઈ મીડિયમમાંથી પાસ થતું નથી. એટલે ક્રોમેટિક એબ્રેશન અને સ્ફેરિકલ એબ્રેશન બંનેનો પ્રોબ્લેમ સોલ્વ થઈ જાય, કારણ કે રિફ્રેક્શન બી નથી થવાનું આની અંદર અને ડિફ્રેક્શન ફિનોમિના બી ઇફેક્ટ કરતી નથી આમાં, રાઈટ. તો રિફ્લેક્ટિંગ ટાઈપ ટેલિસ્કોપ આ ટાઈપનું વર્કિંગ કરતા હોય છે. ક્લિયર?